In this video, I would like to tell you how to prepare your model so that it could be successfully printed on a 3D printer. Modeling for video games, movies, or any kind of visualization differs from modeling for printing. I will not descend to particulars and describe in the details methods or tools how to achieve necessary results. These topics are extensive and require separate consideration. That is why now let's talk about the result. What exactly do you need to get at the output of modeling if you're going to print your model? Here are the examples of 3D printers and printed models. High sticks and patterns are the support against which the model leans when printing. Later they're cut off, and most likely a little processing of cutoffs will be needed to remove traces of the support. Print quality depends on manufacturers such as printer, type of plastic, location of model on the printing table, and even on the room temperature. Apart from that, to print a model successfully, you need to follow certain rules and pre-printing treatment. And let's talk about that. Here are the most basic requirements. First of all is integrity or water resistance of model. Then absence of undercuts, file size in megabytes, correct scale and detail of a model, and finally ability to pass pre-printing software test. Integrity. It seems the most important principle for printing. This means that there are no cavities in the model. All its parts are united into a single monolith. After modeling, it is necessary to integrate all the elements of the model and to glue them together. If you look at such model in a cutaway section, you will see a single contour as the result of the Boolean operation. Let's have a look at the model inside ZBrush. For example, the demo solder, where each element is separate, we can see the gaps between the elements. There is the air, and it should not be that way. We need to bool all these elements together into one single monolith. Actually, it doesn't mean that the model is of bad quality. No, that means that the model was created for visualization, but not for printing. The similar situation is with the undercuts as well. As we can see, all the buttons on the model are glued to the base with additional elements. They do not hang in there, and they do not adjoin to the model partially, but adjoin completely and well attached to it. If small elements such as buttons or belts, any detail adjoin well to the base, they will not fall down and will not be printed partially. The model should not have any gaps between the parts. Imagine that the model is placed into a liquid, and liquid should not leak into the gaps or pockets between the parts. There is another example of undercuts. A bow does not adjoin to a coin. The antenna and edges of a bow are very thin, and they will not be printed or will fall down even at a touch. Therefore, it is necessary to add additional geometry onto the bow, to glue the undercut, as if to project this element on the base. If plaster or rubber mold should be made out of the model, these undercuts or reverse angles will not allow pulling out the mold. It is easy to miss them with a naked eye, So it is recommended to check the model in cutaway section using special pre-printing programs. What can happen if we miss the undercuts and do not unite all the parts of the model to each other as it should be? Here is the example when the backpack had undercuts. There was very small thickness and air inside the backpack, which led to its destruction, unfortunately. It would be more correct not to make the backpack thickness at all, but to deepen it into the base model and then unite it with the Boolean operation. Next, I would like to talk about the file size. The model should be easy to use. It should not overload your computer or printer, so you need to reduce the file before sending it for printing. Here is the example of the same file before and after reduction. The difference is huge, and there are several ways or several methods to reduce the file size. For example, decimation in ZBrush or triangulation in such software like Materialize Magics. At the same time, the model does not lose any quality. After printing these two files, you will not see any difference. However, it is important and desirable that your model could be easy to use. Large files are difficult to move. It takes a long time to load and calculate them before printing. Keep in mind that your model will be printed along with the rest of the models on the table, and it should not overload your computer. Therefore, please just check the file size and reduce it before sending. As a rule, on a 3D printer we print small-sized models such as miniatures or jewelry. Needless to say about the correct scale of the model for printing. First of all, you should double-check the units of measurement you work with and not send in centimeters what should be printed in millimeters. The print specialist may notice an error and indicate that the model is too small or too large, but he or she should not know and cannot know how large the model should be. Thus, for example, Bismarck's head here is about 15 millimeters, and the visor on the helmet is not of the same thin as in life, but thickness. Otherwise, in case of downscaling the model, we get a visor so thin that it may not be printed or crumble because we work with very thin plastic. Such parts on the helmet, as well as fastener or rivets, are also enlarged because they should be visible in real life with the naked eye. And vice versa. If your model has very thin pattern, which goes beyond the printer's resolving capacity, probably you should not draw them at all. Very small parts will be smeared and merged and will not be printed at all. Therefore, specify printer's resolving capacity, the desired quality of printing, and keep modeling those parts which are smaller than that. The next principle is ability to pass the pre-printing software check or STL check. This principle can also be called purity of geometry. Definition fixed file is mentioned when we talking about the file consisting of one single object monolith, when it has no holes, open triangles, and when it has no crossing or overlapping triangles that creates double surface. The model should be tested before printing in such programs as, for example, Materialize Magics or NetFab or their equivalents. For example, the demo solder, which was simply exported from ZBrush, shows that there are many errors. The model has not been cleaned up yet. Errors arose because the thickness of glasses is so small that triangles of front and rear glass walls lay in the same coordinates. They overlap each other, forming intersections and overlaps. This model was not made for printing, it was created for visualization, therefore it requires gluing and removing the intersections of triangles beforehand. The already fixed model of a dog is an example of how ideally the model should be prepared for printing. One solid shell without torn or broken outline, without intersecting triangles, so this model is ready to be sent to the printer. The chronological steps that needed to be taken to comply with the principles of printing can be summarized in the following way. First three blocks, model integrity, undercuts, and scale, are referred to the stage of modeling. Initially, when you create a model, you should keep these principles in mind, and by the end of modeling, almost everything is ready for printing. Last two principles, light file and successful check, are pre-printing preparation. They should be done after the modeling. Thank you very much for watching. I hope that was helpful and enjoy your printing. Bye.